Welcome to your geometry recorded live session of the week. We are in week 14, and it's the week of November 15th. We are going to start with a warm-up problem that relates to what we've been learning so far in Unit 3 about quadrilaterals. And those are those types of questions where you have to respond with sometimes, always, or never. And I did note that some of you guys had trouble with these last week, so I just wanted to go over how we answer those types of questions and some strategies for doing so. And so at this time, I do want you to make sure you've got your math notebook out so that you can take good notes. And I have a diagram over here to the right that I think is super helpful when I answer these types of questions, sometimes, always, or never. So let's just review for a moment what this flow chart means. So remember, we've been learning about different types of quadrilaterals. Everything we've been learning about, every shape in Unit 3 is a quadrilateral. Every shape has 4 sides. Now we started to learn more specifically at the beginning of Unit 3 and throughout the first half about parallelograms. And parallelograms have some characteristics such as opposite sides will be congruent, opposite angles will be congruent, consecutive angles are supplementary, meaning if we add the two that are right next to each other, they'll add up to 180. The diagonals will bisect. So those are all the properties of parallelograms. Now, rectangles, rhombuses, and squares will have all the same properties of parallelograms. So a square is going to have all those properties I just talked about. Opposite sides are congruent. The angles opposite each other are congruent. The diagonals will bisect. The angles are consecutive, but then we've got some more properties that we're going to add on to all those properties that we just listed. And that's that every angle will be 90 degrees, and that so if we were to draw on the angles, or I'm sorry, the diagonals, they would intersect the angles and make those congruent. The diagonals in itself, they are equal to each other, and they also bisect at 90 degrees. So, and then we've got special properties about rhombuses and rectangles as well. So the important thing to remember, though, is that rhombuses, rectangles, and squares share all the properties that parallelograms have. So squares are a type of parallelogram. Rectangles are a type of parallelogram. Rhombuses are a type of parallelogram. And as we go down the flow chart, so rectangle is a type of parallelogram, and a square is a type of rectangle, which is a type of a parallelogram. So if we go backwards here, squares will have all the same properties of rectangles and parallelograms. Squares will have all the same properties of rhombuses and parallelograms. So you can use a flow chart to help you, or you can use a chart that lists all the properties and has X's to let you know which properties each of those have, but those are really helpful to answer those sometimes, always, or never questions. So if you want, go ahead and click pause and try these two on your own, and then we're going to answer these together. So if you want to click pause, try them on your own, and then check your work with mine when you're ready. So the first question is, a square is a rhombus. Is that sometimes true, always true, or never true? Always true, sometimes true, or never true? So a square is a rhombus. So does a square have all the properties that a rhombus has? It does. So remember, a rhombus has opposite sides that are equal, and that's a property of a parallelogram, but now it's taking it a step further, and all sides of rhombuses are equal. Are all sides of squares equal as well? Yes. So a square is always going to have all the properties that a rhombus has. So because it has all the properties that a rhombus has, a square then can be considered always a rhombus. So we would say always in this case, because it has all the properties. A square has all the properties of a rhombus. So it would always be considered a rhombus. Now if we reverse that and asked if a rhombus is a square, we're going in the direct or in the opposite direction now. And we would have to say sometimes, if we flip that around and said, is a rhombus is a square. And that's only sometimes. There's only going to be some cases. A rhombus does not have to have all the angles that are 90 degrees. It might sometimes, but it doesn't have to, so that would be a sometimes. So I just threw that one in there. The last question, though, is a pellet parallelogram has 4 congruent angles. So a parallelogram has 4 congruent angles. Well, a rectangle has 4 congruent angles, a square has 4 congruent angles, and a rectangle and a square we know are types of parallelograms. But what about a rhombus? Does a rhombus have to have 4 congruent angles? No, only the opposite angles need to be congruent. So a rhombus is gonna make this turn into a sometimes. Sometimes is the answer. So a rectangle and a square has 4 congruent angles, and both those are types of parallelograms, but rhombuses do not have 4 congruent angles, and a rhombus is a parallelogram. So because only some of our parallelograms will have 4 congruent angles, that makes this a sometimes answer. So I find that those flow charts or any types of charts are going to be very helpful in answering those sometimes, always, or never questions. I'm going to go on the next slide, so if you need more time, go ahead and click pause. So this week is kind of a little bit of a shorter week in the sense that we don't have school on Monday because of Thanksgiving Day break. So this week we are going to be finishing up all the new content that we're going to learn for Unit 3. Our last session in Unit 3 where we're learning new material is Session 8, and that's where we're going to learn about kites and trapezoids. We're going to learn about kites and trapezoids. And then this week you're going to do a culminating project on quadrilaterals, and then no school next week. But just a reminder that Schoology is available for you guys next week. So even though there's no school next week, Schoology is available for you to work in if you need to get caught up. And I highly, highly recommend, if you're behind, to take advantage of that week that we have off to get caught up. And the reason is because currently we only have about 5 weeks left in the semester. That means after break, you're only going to have about 3.5 weeks left. So when we get back after Thanksgiving break, this end of the semester is going to come really quick. If you are behind, take advantage of this kind of built-in catch-up week that you can use to your advantage. Just remind yourself that I am not available next week during break. Your teachers aren't available, but Schoology is. Okay. Chatted really about all this already, so let's jump right into trapezoids. So a trapezoid is a type of quadrilateral. Is a trapezoid a type of parallelogram? Well, look at this one right here. Are the opposite sides congruent? No. So trapezoids and kites are not parallelograms, but they are quadrilaterals because they have 5 sides. So a trapezoid is defined as a quadrilateral with exactly 1 pair of opposite sides that are parallel. So remember that this little tick here, or these little arrows, that means that those sides are parallel. So if there's those little arrows, that means 2 sides are parallel. And you just need 1 set of opposite sides that are parallel in order to be a trapezoid. And then, so that's what a trapezoid is. And then an isosceles trapezoid, just like an isosceles triangle, an isosceles trapezoid is a trapezoid that has a set of congruent legs. So if you have 2 sides that are parallel, opposite sides that are parallel, and then 2 sides that are congruent, you've got an isosceles trapezoid. If you do not have any sides that are congruent, you just have a plain old trapezoid. And another thing then, just like an isosceles triangle where the 2 base angles were congruent, the same thing is true with an isosceles trapezoid. Your base angles would be congruent. All right. So let's talk about all the different types of theorems or properties of trapezoids, just like we had properties of our parallelograms and the special types of parallelograms. So if a trapezoid is isosceles, if you have two sets of congruent sides, two sets of parallel sides, then the bases are congruent. I just chatted about that. So these two would be congruent, and then these two angles are going to be congruent. The adjacent angles are supplementary, so that's similar to what we did with any adjacent angles are going to be supplementary, just like with parallelograms. So if we add these two, they'll be supplementary. If we add these two, they'll be supplementary. If we add these two, they'll be supplementary. Supplementary, of course, adding up to 180. All right, so let's use some of those properties that we just learned about and apply it to a problem that we can solve. So here we've got an isosceles trapezoid because we've got two sets of parallel lines, and then these two ticks let us know that side SP is congruent to side RQ. Now we are given one angle measurement. The angle S is 50 degrees, and we want to find all the other missing angles. So let's start with the measurement of angle P. So can we figure out what the measurement of angle P is? So remember, we just learned, what did we learn about the adjacent angles? So angle P and angle S are adjacent angles. What did we learn about the measurements of adjacent angles? They have to add up to equal what? 180 degrees. And if we know that the angle of measurement of angle S is 50 degrees, I'm going to substitute that in. That makes it easy for us to solve for the measurement of angle P, because we would just subtract 50 from both sides, and that would give us the measurement of angle P has to be 180 minus 50 is 130 degrees. Now the rest should be really easy to find, right? What do we know about the measurement of angle S and angle R? What do we know about this angle here and this angle here? Since it's an isosceles trapezoid, we know that they're equal, that the measurement of angle R has to be equal to the measurement of angle S. If we know the measurement of angle S is 50, then we also know that the measurement of angle R also has to be 50 degrees. And then the same is true for P and Q, right? So angle P and angle Q, those are two base angles and they have to be equal. So that means that the measurement of angle Q also has to be 130 degrees. So because this was an isosceles triangle, we knew that the base angles are equal to each other. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. Trapezoid theorems. One thing that I did not tell you yet, in an isosceles trapezoids, the diagonals are congruent. So really that means that the length from D to B has to be equal of the length from A to C. So that's another, and then same with, diagonals are congruent. And it's an isosceles trapezoid. I'm so used to saying triangle. It's only an isosceles triangle if if you can prove that those diagonals are congruent, then we know that it's an isosceles. So let's let's do number 1, and then we're going to move on. So let's look at another example using diagonals now, and the idea that diagonals have to be congruent. So we are given the length from J to N, so from just J to N as 10.6, and then we're given N to L, I'm going to do a different color here. N to L is 14.8. And we need to find K to M. Well, what do we know about the diagonals? We know that the diagonals have to be congruent, right? So we know that JL has to be equal to KM. Do we know the length of JL? We don't, we're not given it specifically, but we're given each segment. So JL is just going to be when we add those two together, when we add the two givens, that 10.6 plus 14.8, that's going to equal JL. So 10.6 plus 14.8, we add those together and we get 25.4. So that's the length of JL. JL is, when we add those two together, we get 25.4. And we know JL has to have the same length of KM, so KM also has to be 25.4. So you'll be using that idea about the diagonals with trapezoids this week. I'm going to go to the next slide, so if you need more time, go ahead and click pause. I'm going to skip this one. I kind of want to go, yep, the mid-segment of a trapezoid. So the mid-segment of a trapezoid is a segment that we draw in between our two bases. The mid-segment has to be parallel to our two bases. So all these are parallel. And so if you see here, the mid-segment is this segment right here, M to N. That's our mid-segment. So it's parallel to both of our bases, and it's got to be halfway between this segments right here of these legs. So the mid-segment would be halfway between A to B, halfway between C to D. So you can see those ticks in here showing that mid-segment does happen halfway between there. And once we know that it's properly placed, the mid-segment, the length of the mid-segment is half of the sum of the bases. So what does that mean? That means that the length of MN is going to be equal to half of the sum of our two bases. So our bases are BC plus AD. So if we add our bases together, divide it by 2, it's going to be the length of our mid-segment. So that is the mid-segment theorem. Let's do a problem with the mid-segment theorem. So we've got a cake here, a layered cake, and a baker is making a cake like the one on the right. It's a layered cake. The top layer has a diameter. The top layer has a diameter of 8 inches. So remember, diameter is all the way across. It's going to be 8 inches. And the bottom layer has a diameter of 20 inches. How big should the middle layer be? So we were given the length of our two bases, and we need to find the length of our mid-segment, because that's what the mid-segment is right here. So I'm going to go to the next slide. Whoops. So not yet. So can you guys see what I labeled? I wonder if it's better to do like purple maybe here. This one's 20. So to find the length of our mid-segment, how do we do that? So remember, we have to add our two bases together, so 8 plus 20, and then we have to take that and divide it by 2. And that's going to give us the mid-segment, the diameter of the mid-segment. So 28 divided by 2 is 14 inches. That's it. That middle layer should be 14 inches. I'm going to go on to the next slide. So we can do this same theorem, apply it even when we have variables. So here we've got a trapezoid, and we've got the mid-segment. We know that this right here is our mid-segment because it's located halfway between the bases. So how do we solve for x? We're going to solve for x using the mid-segment theorem. So what does the mid-segment theorem state? That the mid-segment should be equal to 1/2 the sum of our bases. So I'm just going to add up our bases. Even though they're not numbers, I can still put in my two bases and add those two together. So now I can just work on solving for x. I'm going to add all of our like terms. I've got 3x's and -7. So now when we've got the right side being divided by 2 or multiplied by 1/2, the next thing that we need to do is get rid of this 1/2. And the quickest way to do that is multiply it by its reciprocal. We've got a fraction, so multiply each side by its reciprocal, which would be, 2/1. Whatever I do to one side, I've got to do to the other. So I'm going to multiply each side by the reciprocal of 1/2, which is 2, or 2/1, to get rid of that fraction on the right. We don't want that fraction on the right. So now we've got 2 times 10 is 20. Then we just got that 3x minus 7. We got to solve for x, so we're going to add 7 next. 27 equals 3x. Divide each side by 3. 27 divided by 3 is 9, so x would equal 9. So we solve for x. X would equal 9. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. Again, we set up to solve this problem using the properties or the theorem of that mid-segment theorem, and the idea that the mid-segment is half of the sum of the bases. Now, the rest of Unit 3, Session 8 is going to talk about kites, and I'm just going to go over the properties, and then I'm going to have to stop because I know this recording is getting a little long. So, kites, we've got 2 vertex angles right here. These are vertex angles. Those are called the vertex angles. And I shouldn't put those, that's going to look like they're congruent, and they're not necessarily congruent. We've got 2 pairs of adjacent sides are going to be equal. So your adjacent sides would be equal. You can see here. The angles are equal where the sides meet. So our non-vertex angles, that's going to be the only place that we have congruent angles, our non-vertex. So where the sides meet, the non-vertex angles are going to be congruent. The diagonals are always going to meet at right angles, and the diagonals bisect each other. One right here, those are the only set that bisect each other. One set does. And then it's the diagonals bisect the, I should say vertex here, vertex angles. So, you're going to learn more about kites in this week's lessons, but that's just a little preview of what you're going to see, and then you can apply those properties to solve different problems. So time for our key phrase assignment. So my question to you is, we learned about trapezoids today. We reviewed parallelograms, and I want you to tell me if trapezoids are considered parallelograms, and then tell me why or why not. And that's your key phrase question for the week of November 15th. If you need a reminder of how to complete those, the directions are down below. Otherwise, have a wonderful rest of your week, a wonderful Thanksgiving, and if you need help with this question or with any of the questions that you come across this week, remember I'm always here to help.